Hello, so this is Pallavi Verma, and so yeah, it's been a long time. So today I have come up with something new, which is binary tree. So this is part of data structure and algorithm, as we all know. So let's try with binary tree first, and we will see how we can insert a node in a binary tree. So let's create a class first. So let's give the name, let's say binary tree, and I'm gonna add a main method. Okay, perfect. So let me create the class first. So let's say it's a BT class representing a binary tree. So what kind of binary tree I want? I can have an integer number over here, and that number is nothing but going to represent a node, or maybe we can have a string that is going to represent that node. Okay, so let's say I'm going to have a string, so string name. Now what I need is I need to have its children, so it's going to have two children's, at most two children's, right? So let's take the left and right children. So it's going to be type of the tree itself. So I'm going to have this left, and similarly I'm going to have the right. Okay. Now I'm going to have a constructor so that when we insert, we will have the name, and using that name I'm going to create the node. So this is my class name, and I'm going to create the constructor. So here it's string name, and this dot name is equals to name. Oops. Yeah. Okay. And also when we are creating a node, it's not about just the name. It should have its children's too. So we need to take care of that also. So I'm going to have this left is equals to null, and again I'm going to have its another children, which is I'm going to have its another child, which is right, and it's going to be now. Perfect. Now what I can do is I can have all the getters and setters. So instead of writing manually, I'm going to generate it from the source itself. So yeah, select all, generate this. Now our tree is created in terms of how it should look like in terms of node itself. Now we need to perform an operation using which we can insert a node in a binary tree. So let's create a separate class for that. So let's say it's going to be BT operations. So here I'm going to have the private root. So as we all know the concept of tree, there would be a root node. So all that theory stuff I'm not going to cover over here. Oops, it's going to be BT. Yeah. So now what we need to do is we need to think in a certain way where a tree has a root node, and we have to insert the other nodes, which is nothing but its children. But we need to start with the root itself. So what I'm going to do is I'm going to have a one method, which is, let's say, create root item, and this method is going to give us a root node itself. So I would say, okay, root is equals to new BT, and then okay, I'm gonna take one. Now we are going to have the constant. So private static final, and we have this root item. Okay, let's say it's your root item. Now I'm gonna create a node for this root item. That's it. Now, since we need to insert a new node, or every time we can trigger insert operation to insert a node. So for that I'm going to create a method. Let's say public boolean, boolean, the name should be okay, insert node, and this method is going to have a parameter. Let's say it's a string name, or I can say node name. That looks better. Yeah. So obviously I need to return something. So right now I am returning a false. So let's start with the base case and some checks that we need to do. So node name is equals to null. So what if the string value that we are passing is null? So we have to handle that case. Or node name, if it is empty, in that case how we have to handle it? So we are simply gonna return false, right? Because that's not a valid node. Now what if we will check, okay, whether the incoming node should be a root node or one of the child of the node. So for that we need to do this null check for the root node itself. So if it is null, we are going to call create. I'm going to make a call to this function, and of course we don't need any parameters as per the function. So now we have to handle the incoming node value. It could be string, it could be integer, but we have taken a string, so it's going to be a string for now. It could be integer also, but you have to change the data type over here. So it's a string, so I'm going to handle it as a string. So let's start. So what I'm going to do is, since we have already made that null check, I'm directly going to create a node for that. So I will say that, okay, bt, a new node, and new bt, and the value, which is nothing but node name. Okay, now we have to follow the logic of traversing, and we need to make sure that how bt exactly works. As I mentioned, I'm not going to cover the theory part over here. So this is my assumption that you know some basics about bt. So let's start adding the node. So I have already created a node for bt. Excuse me. Now what I'll say that I have to simply traverse over that. So why not to make a new method? Let's say insert, and I'm going to pass root and node name. So let's create this method. Okay, I'm gonna change this root to node itself. Now I'm gonna check if the node dot get left, if it is equals to null, then what we should do? We need to add, and here of course I need to change the data type, and yeah, now it looks good. I would say that, okay, node dot set left. What we need to set? We need to set the node itself. Something is okay, sorry about that, and it is going to be bt itself, and let's say new node, and I'm going to give that node itself, and I would say that, okay, return it from here, which is true. Okay, similarly I'm going to do it for the right node. White is this. Again we have to set right node, returning. So I hope you understood what exactly I did over here. So this is our current node. First I'm gonna check if the current node left is null, then I'm going to insert the incoming node, this node. If not, then I'm going here and check whether the right of the node is null or not. If yes, then I'm going to insert that. But what if the current node has already both the children? So let's say you have node A. Node A has left children B and right children C. And let's say we are passing children D. Where it will go? It will go to B node, which means B's left will have D node. So I hope you understand the BT concept. So that's the tricky part over here, and that we are going to handle. So what we are going to do is, I'm going to say, okay, I need to put a recursion, okay, because recursion is the best way when you are dealing with such questions. So insert, what I need to insert, since I have already checked left is not null, right is not null, which means I have to go to its left children and again need to find whether its right and left children are null. So starting with the concept, left to right, not right to left. So what I'm going to do is node dot get left and the new node self. But what else I need to do? Because if I put it like this, it may go into some infinite loop. So how we can avoid it? I will say, okay, I'll put a conditional check. If this gives me true, then only you return. I hope you all know how recursion works, because if you don't know, it's going to be little difficult for you to understand how exactly this will work. Okay, now what I can do is, I can simply say that, okay, return insert, and this time I'm going to pass node dot get right and the new node itself. So this is how you can insert a node in binary tree. Let's complete its main method. Okay, so this is our main method. So this is our operation class BTOPE. So I'm going to create the object of BTOPE. Let's say tree is equals to new and BTOPE. Yeah, perfect. Now tree dot, we need to insert it. So we need to find the appropriate method for us. So insert node, let's say you have A. Now again I'm going to have this insert, and let's say B. Let me copy it. So this is how you can create your tree node, and then you can insert node. And I hope you liked it. If you have any confusion, you can just drop a comment. I'll check and try to respond it. Thank you.